This is Star Talk. This is Star Talk, and I'm your host, Neil Degrasse Tyson. I'm an astrophysicist, your personal astrophysicist. My day job is as the director of the Hayden Planetarium of the American Museum of Natural History right here in New York City. And as always for Star Talk, my co-host is a professional comedian. Today we have with us Eugene Merman. Eugene, thanks for being back.
Very glad to be here.
Yeah. What you been doing lately?
I've been touring. I have an album that came out.
Touring and albuming.
Yeah.
Okay, cool.
That's largely what I've been doing.
Because that's what stand-up comedians do.
Yeah, they release an album and they tour. Well, everybody does that, where they're like, tell people about their album. Okay, sometimes you can do it on the radio.
Except I read this is not an album. This is like nine. It's
9 volumes. It took a few years to make. It's full of a lot of ridiculous things, a meditation, sound effects.
Wow.
45 minutes of crying. That's one of the volumes. It is.
So people lined up to buy this?
Well, you don't have to line up anymore. You can use the internet.
Oh, I gotcha.
Yeah.
Oh, good. Gone is that expression.
Yeah, exactly. Hopefully 2 people stood in line. I mean, there's also stand-up. It's a normal album, and it's not like... anyway.
So this edition of Star Talk, Cosmic Queries, we've solicited questions from our fan base and all the different social media platforms, and you're going to read them to me. I've not seen them before. Yeah. And what is the theme today?
The theme is new discoveries and new mysteries of the universe.
Oh, okay.
So I hope you're up on your new mysteries.
I don't know if I'm up on this.
We'll find out.
Because I'm classically trained, and so I know. So I know stuff.
Yeah.
But if I'm like turning the page of the very latest discoveries, I'm maybe not. So I'll let you know if that's the case. Okay, bring it on.
Nicole Brooks from Patreon asks, based on the expanding knowledge of wormholes and Tipler cylinders, do you think it is theoretically possible to travel through the past or the future using one of the following devices? Only wormholes, only Tipler cylinders, or wormholes for present/future travel and Tipler cylinders for the past?
The answer is yes, it's theoretically possible because you can show how moving through a wormhole can put you back in the time frame from which you left.
Mm-hmm.
You can show that. But we don't know how to make a wormhole. It's not a realistic thing yet.
But theoretically, once we figure out how to make them...
equations tell us we can do it, unless, having made the wormhole, we then make discoveries that tell us that we can't.
Right.
And it's been hypothesized by Hawking, among others, that there might be a universal law of physics that prevents you from traveling backwards in time. Because suppose you did this and you prevented your parents from meeting one another, then you would have never been conceived enough to go back in time to prevent them from meeting one another.
Right.
So this would be, it's a temporal paradox.
Yeah.
And maybe the laws of physics, when we get there, will tell us about this paradox and therefore prevent it.
Right. Or create another, could another universe be created?
The many worlds
theoretically...
hypothesis. Yeah. It's like at any point where a past event is changed, then a new universe spawns off. That was just a way to not have to really answer the question.
Right.
That's how I've looked at it.
Okay.
Yeah. It was given serious theoretical and physical thought behind the New World's interpretation that was invoked for quantum physics back in the 1920s. The weird things were happening, and maybe all things were happening, and we were just choosing which path through reality accounted for what we saw.
So you're not convinced that Back to the Future trilogy is possible?
Certainly not the Cubs winning the World Series, apparently, as they should have done this October 2015.
All right. Well,
all right.
Good. Okay, so from Facebook, a doist in here asks, what if there is an alien megastructure? What would that mean for humanity? So probably this questioner is referring to one of the suspected exoplanets that Kepler, the telescope, discovered. Yeah. And normally what Kepler is looking for is a slight dip in the light of the host star as the planet eclipses in front of it. So the planet will drop it by maybe 1%, and we can measure intensity of light accurately enough and with enough precision to say how big the planet is, what its orbital period is, and all the like. But it has found something that is some structure that has no resemblance to planet, to the signature of a planet. And it's been suggested maybe they were building one of these Dyson spheres where if you want to way to think about it is, what are we doing to get energy? We're like fighting wars,
right?
Digging
Stuff
fossil
out of the ground.
fuels out of the ground. All right, that's pretty primitive.
Our plants eat our sunlight.
They do.
That's not how they describe it, but I'm not wrong.
So there are levels of civilization that you can reference depending on how sophisticated they are in obtaining energy. So one of them would be you can tap energy from Earth. So volcanoes, earthquakes, tornadoes, cyclones.
We should start charging our phones with tornadoes.
Exactly. If you can do that, then Earth is supplying all the energy you need. Or it's a source of energy unlike anything you might have had before. Well, can you go more than that? Yes. You could tap all the energy that your host star can give you. Well, how would you do that? Well, you can put up solar panels, but you can only put that on the surface of the Earth. But it's sending energy out in every direction in space. So why not put up solar panels all around the star? So all the energy that leaves the star hits the solar panels, and you take every ounce of energy that star has to give you. That's another level of civilization.
And then how do you get that to your planet?
Well, you'd wire it up or whatever. I mean, you have to.
You'd have a very long cable.
Yes.
Or if you can do that, you might have some solution.
Exactly. You figure that out. And the next level of civilization is you command all the energy of all the stars in your galaxy. And the highest level would be commanding all the energy of all the galaxies in the universe. So we would have to be a higher level of civilization to be able to maneuver and manipulate wormholes. And so we're not there yet. We are so far from it yet. So there you have it.
Okay.
Yeah. What's next?
Next is James from Facebook. He asks, what is New Horizons' mission now? Or is it just drifting towards the Kuiper belt?
Yeah, so the New Horizons mission, that's the mission that went to find Pluto and did a flyby, got awesome data from Pluto, close-up, high-resolution images that are still coming in. The spacecraft was pared down in weight so that it could get to its destination as fast as possible. Because the number one rule in science is what?
Go very quickly.
You want to finish your experiment before you die.
Right.
Yeah, so going quickly would matter.
Yeah.
So you have the lightest...
So I'm not totally wrong.
Yeah, you're not totally wrong. So you want the lightest spacecraft and the most powerful boosters to get you there, and that's a potent combination for getting there quickly. So we got to Pluto in 10 years.
Yeah.
And we passed the moon's orbit in 9 hours. I mean the spacecraft.
Yeah.
In 9 hours.
Humanity.
It took the astronauts 3 days to cover that distance. So this thing's booking out of the solar system. So it passed Pluto in a flyby, and now it is not adrift in the Kuiper belt. They're selecting targets for it. It still has fuel, so it can maneuver by a certain angle. And that angle is enough to have it come close to other frozen bodies in the outer solar system whose properties resemble that of the moon.
And it's sending that info back to us as well?
It will when it gets there. That's correct.
Okay.
Yeah.
Okay, great.
All right.
Jared on Facebook asks, to build megastructures in space, wouldn't you need something, say, the size of a mineral-rich asteroid belt or a moon mined for the same?
So what they're saying is if you're going to build a huge structure in space that uses more mineral resources than your planet can supply, yeah, you'd have to get the stuff from space.
Yeah.
But that's not a problem because we know the asteroids are an unlimited, essentially limitless supply of all the ingredients that would otherwise be rare on Earth. So the rare Earth elements, they're only rare on Earth.
Right. They're not rare in asteroids.
In particular, hand-picked asteroids. So yeah, you would need resources from beyond your home planet, but people are well aware of that.
Yeah, and I think if you're building this megastructure, that's what you'd do.
Correct.
That's how I would do it.
Yeah.
Dave Massey on Facebook asks, what needs to be improved in carbon nanotube technology to build large space structures?
Well, so first of all, some years ago, I forgot what year it was. Was it 1989 or 90, when they discovered a new molecule, carbon-60. This is 60 carbon atoms. That the way to make 60 carbon atoms into one molecule is you can connect them in a particular way where they end up making a sphere. And that sphere was the vertices of the geodesic dome that was advanced by Buckminster Fuller. And so these spheres came to be known as buckyballs. And I think they are the same seams and nodes that you find on a stitched soccer ball, the older soccer ball that has hexagons and pentagons. So there it is. Now, if you cut it in the middle and spread it and then put carbon fibers connecting one side to another, you go from a carbon buckyball to a carbon nanotube. So it's the same scale of chemistry. And so this would be way stronger than steel, way lighter than steel. It would completely transform the construction industry because you want things that are strong but light.
Yeah.
This is kind of how that works.
Sounds like transparent aluminum from Star Trek 4.
Exactly, I remember that. That's the Save the Whales episode.
Yep, exactly.
So question now is, if you can build long tubes, these would replace steel cables for all of your needs and make things lighter, cheaper, faster, better. The problem is, last I checked, the longest nanotube that they've been able to make has been maybe a centimeter long. And because we don't have tools to plant, to position molecules, we have to coax them into these configurations based on the apparatus and the temperature and the pressure and the mixture of other chemicals.
Once they're made, can they live out in the world?
Yeah, I don't see why not, given their strength. And so now the space elevator, where you take an elevator to orbit, is something that would basically require carbon nanotubes. But we have to go from a centimeter length to 23,000 miles of length.
Right.
And we're not there yet.
No, that sounds like it's going to take time.
Right.
Okay, Martin Holden asks on Facebook, what are the books that a budding cosmologist should have in their library?
It depends on what level. But I would say a fun book, just because it's big and audacious, big, hairy, and audacious, is a book called Gravitation. And it's written by 3 authors, Misner, Thorne, and Wheeler. Wheeler was the guy who first coined the term black hole. Thorne was the guy who was the science advisor to the movie Interstellar. And his first name is Kip, and one of the robots in Interstellar was called Kip, by the way. In case you're scoring along with us. Yes, as Bill Nye is fond of saying. And also, he wrote a companion book to the movie Interstellar called The Science of Interstellar. So he's one of the authors, and the third is a professor from the University of Maryland, and Charles Misner. And it's a huge book. It's just called Gravitation. And there are 2 tracks, the WIMP track and the advanced track.
In the book?
In the book.
So meaning, maybe the layman...
Yeah, they're color-coded. And so if you want the easier track, you read the pages with the black corners. And you want the harder one, you read the ones with the white corners.
Oh.
Yeah.
Oh, maybe I'll try it.
So that one, if you're kind of advanced, that's the one I'd recommend.
You can do either one.
But if not, then there's so many excellent popular level books. Brian Greene's The Fabric of the Cosmos, and Lisa Randall has 3 books all about cosmology and our understanding of our place in the universe. So you can start with those popular level accounts and then ascend from there.
Okay.
Yeah.
Amy Danger on Facebook asks...
Great name.
I know. A very good name. My 9-year-old daughter wants to know why our moon doesn't have a name. I'm with her. Why doesn't our moon have a name?
Our moon does have a name.
What, Jeff?
Freddie.
Yeah. What's our moon's name?
So...
Mr. Moon.
So all the planets are named for Latin gods. So you would expect any name for Earth or the moon to be Latin. And so...
You would expect.
You would expect. So the Earth, Moon, and Sun combo have Latin corresponding names. And we can use them in my field. Everyone will know what you're talking about.
What's the name of the moon?
So the name of Earth is Terra.
Terra.
The name of the moon is Luna.
Luna. Oh.
Yeah, yeah. And the name of the sun is Sol.
Oh,
not
Luna.
Not like S-O-U-L, which would be really cool, but S-O-L. And so those Latin words have all been lifted to become the roots of other words. So Sol is the root of solar system.
Right.
And Luna, like lunatic and lunar month and this sort of thing. So, of course, a lunatic is someone who acts crazy after they see the full moon. But they don't tend to act crazy when it's cloudy out.
Right.
They don't even know that it's full.
I didn't know that lunatic specifically was someone who was crazy.
From moonlight. Oh, yeah.
From moonlight?
Why else would you call it lunatic?
Well, no one uses it that way now.
No, exactly.
That's why.
Exactly.
Sorry, that's the reason I thought that is because...
Okay.
Yeah. Wow, that's great to know. So, Amy, the moon does have a name, and it's Luna.
Yes, Sol, Terra, and Luna.
Nice. Martin Holden asks on Facebook, is space continuous or granular?
All evidence points to that it's granular in quantum physics, which has been trumping every other field that it has touched. It's the most accurate theory of the universe we have ever put forth. Tells us that space is granular. That there's
what does it mean for it to be continuous?
There's the smallest possible length that you can measure in space. There's the smallest possible unit of time that can exist in space. And this granulation of space and time would tell us that, in fact, space is not continuous. By the way, general relativity, Einstein's theory of gravity, requires that space be smoothly continuous. So there's a shotgun war going on there about who's going to be right in the end. And if you're a betting person, you put your money on quantum physics.
Really?
Yeah.
Wait, so that means that if you were to get to the edge of the universe, then what would be?
It says nothing about the edge of the universe.
Oh, okay, it says nothing about that.
It has to do with how small you can divide the fabric of space and time.
Oh, I see.
By the way, this is not a weird concept.
Right.
If you take a sheet and you say, okay, give me a section of the sheet, and you cut a section, fine, and I give you a 1 foot square, let's say, and now you say, I want a smaller section. I give you 1 inch square. I want an even smaller section, 1 millimeter square. Now, suppose you're asking me for a section of the sheet that is smaller than the fibers are tracking within the sheet. Is that still sheet?
Ooh. Yeah.
Your fibers, and then now you're in a zone within the stitches of the fiber where there's no sheet at all. So pieces of the sheet are no longer heterogeneously represented.
Right.
Because your sizing is smaller than the stuff that's constructing it in the first place.
So now you're going to its building blocks is what you're saying.
Exactly.
Yeah.
So right now everything looks continuous because we're not dealing with these very small sizes.
Right.
But when you do get there and you try to measure time, you'll find that you won't be able to.
And it's granular.
Yes.
All right. Now I understand.
You know what I just learned recently? Just freaked me out, and I have to read up on it because it's not where. So I learned that some ideas of the expanding universe will have the universe in some places where the space-time fabric itself melts.
What does that mean?
I don't know.
You don't know what it means.
I tried to. I'll come back to you on this.
Okay, because I'm very curious what it means for space-time to melt.
Right, that space-time might have corresponding states of matter going on within them, and you might be able to melt space. And I just
oh my god! And then you could drink it. I can't wait to tell people I've drunk 1 liter of molten space.
Yeah, I wonder what that would be like.
I don't know.
Yes,
I hope we all find out in 2058.
We'll come back to Cosmic Queries, wondering what are the new discoveries in the universe. Stay with us. We're back on Star Talk. I'm your host, Neil deGrasse Tyson. Eugene Merman right here. Eugene, what do you tweet at?
At Eugene Merman.
I knew that.
Yeah,
I know. I just want to get you to say that.
Yeah, no, you tricked me. Now it's like Mixelplex. You've said my name forwards, and I'm still here.
So it's great following. I do follow you, and it's great just hearing your reflection. Sometimes is he serious or is he? Sometimes I wonder.
What? Maybe I mean both.
Maybe comedians need more emoticons to surround their. It's just so we know where
surround our irony.
And there's another one. Who did I see joke about this? They said back in my day, we had to use our face to make emoticons. Just so you've got questions from our fan base, and it's just about new discoveries in the universe. And if I don't know it, I'll just say I don't know.
I'll answer it anyway. Some misleading. Okay, here we go. William on Twitter asks, what are your thoughts on the mysterious structure orbiting a star 1,500 light years away?
Yeah, so that's related to the earlier question about alien megastructures.
Yeah.
So I don't know what that structure is. By the way, I don't think I detailed earlier. These structures that pass between the telescope and the host star, we know it's not a planet.
So what are some of the options and what?
It's dimming the light in odd, significant, and unusual ways of the host star.
That we've never seen before?
Never seen. And that's why people are thinking they're building structures to grab the sunlight, the starlight, and beam it back to the home planet. So I tend to be very conservative in my scientific...
Advanced alien civilization
on the subject of advanced alien civilization. And I would say, just because we do not know what it is, it does not then mean it's alien megastructures.
Right.
You just
it's just something we don't know.
It's so, and I said it's probably something more mundane, accounting for it,
like a super thick cloud of space debris.
Possibly, I don't know.
What are what kinds of... So alien megastructure is one theory. Any other... One hypothesis, sorry. Right. Yeah. So what are some other hypotheses?
Yeah, because there's the theory of evolution, the theory of gravity.
Right.
And
the hypothesis.
And Eugene's hypothesis.
Yeah.
It's not Eugene's theory.
Theory is once it's been agreed on. And,
and it's very powerful. And
a hypothesis is like, this is a very good guess.
And you just came up with it on the spot.
Yeah.
Right.
So what are some other hypotheses? So alien megastructure. Well,
maybe a cloud of comets that had broken apart, but were still traveling together as a gang.
That's a pretty good guess of mine.
Yeah, if you have a huge comet and you break it apart into multiple pieces, all those pieces still travel together in orbit around the sun, kind of like in a pack of cars, like in NASCAR.
Like a bunch of birds.
Yeah, they'll slowly separate, flocking. Yeah, they'll slowly separate, but not until you get some good movement there. So if you start with a huge comet and it breaks apart into 100 pieces, now you have more blockage of your host star. But it still was not repeating periodically, which any orbiting object would do. So it's a tremendously fascinating mystery. And I'm content in knowing it's a mystery. I don't require of the mystery that it yield a solution on the spot.
John on Twitter asks, as the universe expands, will the Higgs field expand and thus weaken to the point of matter degeneration? Same with EMF.
Yeah, so I don't know what effect the expansion of the universe has on the Higgs field. I'm guessing it might dilute it in some way, and the question is, how does that then affect the mass that it grants to particles within that field? So I do not know the answer to that.
Okay.
Do you want me to make up an answer?
No, I appreciate your honesty more. Okay, David on Twitter.
No, wait, let me make up an answer.
Okay, make up an answer. Sorry, wrong answer on my part. Make up an answer.
If it did weaken and that somehow interfered with the ability of the Higgs field to grant mass to particles, that would be completely destabilizing on the universe. That'd be awesome.
And what would happen then?
Well, I don't know. If particles have less mass than we thought they did, or that...
Can I fly? Could I be able to fly?
Just because you have less mass doesn't mean you can fly. No.
But would there be a point at which, though, that would be the case?
You'd need strength in wing flapping.
Okay. Or become super magnetic? What if I could control magnets?
Well, then you're not like Magneto. Oh. Yeah, but then you're not really...
Oh, I see.
I mean, yeah, you need magnets wherever you need to do your tricks. Yeah,
right.
Flying.
Okay, fair enough. I'm just trying to figure out how I could fly, but I don't think that's what he was trying to do. Okay, David asks on Twitter, will the presence of water on Mars affect how we manufacture fuel for the return trip?
Not for the... well, in the future, possibly. Oh, most certainly.
Yeah.
Yeah, because fuel, what is water made of, chemically?
H2O,
H2O,
I'm guessing.
Very nice, very nice. And H2O, it turns out, is rocket fuel. Not in the form of water, but if you separate the hydrogen and the oxygen and you bring them together to make a molecule, the water molecule, then it is hugely exothermic. A lot of energy gets released and it makes an ideal rocket fuel. So if you go to Mars and you want to use resources in situ, then converting the water under the soils into rocket fuel is an ideal usage case, so the future of that expedition.
Okay.
So, yeah.
James asks, what question would you like to have answered before you die, regardless of if you think it will or even can be, and why?
Yeah, so I've got a cop-out answer to that. I like the questions that no one have thought of yet, because they only emerge from having made a discovery that you're after in that moment.
Right.
Those are the questions. So I would not have even known to ask 100 years ago, how many asteroids could render humans on Earth extinct? Because the asteroids were not known to cross the orbit of the Earth. So now I'm asking a question that was unforeseeable.
Right.
In a day.
So it'd be something like, how do we control wormholes to go back in time to kill all our grandparents? But we can't conceive of that quite yet.
Yeah. So this is the challenge, I would say.
The challenge is the coming up with is new discoveries that will lead to new questions.
Yeah. Sorry. So
You're like that?
No. So I think this is my challenge in coming up with the question, because I love the questions that have not even been thought up yet. So therefore, I can't even share them with you.
Right.
But when they do arise, it's like, wow, that was good. That was a good one.
Right.
Yeah.
All right. Lewis asks, theoretically, if a man is sent to Mars for a year, would he be awake and asleep for the same amount of time as an Earthling?
Yeah, I mean, you can set a schedule that's slightly different from Earth. Yeah. Maybe a 25-hour day or a 23-hour day, and people that tend to stay up later in the they're morning people and they're nighttime people.
Yeah,
you could probably take a boatload of nighttime people, put them on a ship, and have them go to Mars and have them live in a 26 or 27, maybe even a 28-hour day. Because they're always staying up late pushing...
What's the day of Mars? How long is it?
It's about 24 hours.
Oh, okay. Oh,
yeah, it's very cool.
So you wouldn't even need
to... No, you wouldn't. No, yeah, it might be different by 20 minutes or something.
Oh, okay.
But by the way, people who work on Mars, or rather scientists, colleagues of mine who study rovers that work on Mars, they have a watch that's made so that a 24 hours on that watch matches the exact rotation rate of Mars, so that they can live on a Mars time as well as human time.
Right.
And
I wonder if they go like, oh, okay, well, I'll see you at dinner at 7, Mars time.
And the reason why they have to do that is they need to know when many of the rovers have solar panels and things, and all of them have solar panels. And so you need to know, when is it exposed to the sun, recharging its batteries, when is it not?
Right. Good answer. All right. Jared has a question, and his question is, would it be plausible to find gravity waves by observing the resonant frequency of, say, a mile-long piano string?
Oh.
Oh. What do you think?
Yeah, so the mass and energy in a piano string is insufficient to generate a detectable gravity wave.
So it wouldn't
you need a major gravitational disturbance in the fabric of space and time.
What would that entail?
A collision of two black holes.
Oh.
Collision of two...
A piano string is not enough then.
I'm sorry, it's not measuring up to the... Yeah, sorry about that. But he's thinking that this vibration would somehow vibrate the fabric of the universe. And no, it would vibrate any kind of air molecules
that
it touched on doing so. And in space, there's no air molecules, so it'll just swing back and forth, but it won't generate sound.
Right.
Because the vibration of the air molecules is what we sense as sound.
The saddest thing is a piano in space. All right.
And any musical instrument in space.
No, just pianos. The trumpet, well, yeah, because it just feels like, because of the cost to put a piano up there. Denard on Google Plus asks, with slowing investments in space-based science across the board in multiple countries, what effect does this have on limiting human discoveries of our place in the universe?
Yeah, that's a great question. And if you're going to cut back on science, which is the current, which constitute the current roads of discovery, then just move back into the cave. Yeah. What are you doing? Now, you can vote for that kind of country, but that's not the kind of country I grew up in.
Right.
We had investments in science and technology. You did not need special programs to convince kids that they should be interested in science.
Well,
it was built into the fabric of the media cycles.
Well, NASA, for every dollar put into NASA, it returns something like $7 or $8 into...
Yeah, I hardly ever cite that calculation because there's a lot of...
Or it's not, is it somewhat accurate?
Yeah, it can be accurate, but it's a matter of what you value that goes into the equation that gets that number. So that's the kind of same calculation you do when you say, well, let's put an opera in town.
Yeah.
Well, how are we going to support the opera? Well, we don't know, but if you put an opera there, then these stores will open up around the entrance to that opera.
Right.
And so it's a seeding effect that many people talk about. But
it's hard to actually say.
It's hard to anchor that in a way that if 5 different people did the same analysis, would they get the same answer? And the answer is no.
And that also isn't necessarily the scientific discovery is partially its own end, not the fact that...
Correct.
Yeah.
Correct. So even though some people want you to do it for some purpose, it's really for its own end. And later on, you find out how it really applies.
Yeah.
Yeah.
All right. Jorgen Nyberg asks, he's writing from the west coast of Sweden on Google Plus.
Jorgen.
Yeah, Jorgen Nyberg.
Mm-hmm.
Any news re KIC 8462852? If not, do you know what the periodicity of the dimming has been?
Yeah, so this is again that
my God, this is more alien megastructure. But he's like,
By the way, wait, as you read it, you sounded like a second grader reading.
Yeah, I mean, well, I also, without knowing the actual number of the planet or whatever, it sounds like maybe it's also a veiled death threat. He's like, any news? Like he's like a code.
Oh, get code. Yeah,
yeah, exactly.
Right. What do you know about?
Yeah.
So no.
Any word? I'm asking on the radio.
No, there's no updates, and it's got people. It's got people thinking long and hard and deep about what it could be. But for me, like I said, I don't know what it is, and I reserve comment.
Okay.
Yeah.
We have one last question.
Okay.
Mark Miller, Patreon, he asks.
So Patreon that's our
funding.
It's you can be a funding friend.
Yeah.
Of Star Talk.
Yeah.
And you get certain perks.
Yeah.
Like, we'll bring your question to the top of the list.
Yes. Well, I had asked one Patreon question, and we have one more left.
One more.
Yeah.
You'll just get to the list faster.
Well, Mark already got to ask one on another episode, so Mark's getting a real ton of questions.
He's getting it in there.
Yeah.
But depending on your participation level, you want to promote the innovations that we're trying to bring to.
Yeah. For $1 million, I'll carry you 9 feet.
Okay.
That's just one thing I'll offer.
I think we can do better than that, Eugene.
If you really love Star Talk, we have to do better than that.
Very happy our Patreon supporters. So thanks for being out there,
yes,
folks. So go ahead.
Let me ask Mark's question. With the discovery of a black hole expelling some of the matter it had consumed, what forces may be responsible for this unusual behavior?
Oh, it's not unusual because it's not coming from within the event horizon. Once you cross over the event horizon, just kiss your ass goodbye. So what's actually happening is all this matter is spiraling towards the black hole center, and it can't all get there all at once. And it forms this disk on which all this material accretes. And the disk feeds the black hole on the very inner edge of it. But until it gets to that point, you still have this assembly of matter, and as it spirals down, it gets hotter and hotter and hotter, and it begins to radiate. It radiates so ferociously, it punches out above and below the disk itself, and then you get these jets, these long spewed forth signatures of moving matter, and so yes, this happens because all this matter is trying to get down into the same place at the same time, and it's going to fail in doing so. And once you heat up a gas, it's got to radiate somewhere, and it'll do it. It'll do it.
Yeah. Oh, it will. Yeah. That's the promise I make to you.
So most of the exotic galactic center phenomenon we've seen with powerful jets emanating from above and below a galaxy and very intense in all bands of light, radio waves, microwaves, ultraviolet, X-rays. So we have established over the decades that the thing that's causing all that violence in the galaxies are black holes with matter trying to get in there too fast, creating these explosive accretion disks. So that's how it comes out of a black hole. And we say it loosely. Oh, this came out of the black hole. No, it came out of the vicinity of the black hole, not out of the black hole itself. But when we come back, more Cosmic Queries on the latest stuff in the universe. I'm Neil deGrasse Tyson, Eugene Merman. We'll see you in a moment. We're back on Star Talk, Cosmic Queries edition. First two segments, we did questions related to the
new discoveries.
Exactly. And now we're going straight to Grab Bag.
All right.
Potpourri.
Let's see what it is.
Let's do this.
Andrew asks, is it possible that the long-term collection of matter, space mining, may cause a change in the way the Earth orbits the Sun or the Moon orbits the Earth? Is there a tipping point of the Earth collecting changing mass from a large asteroid that can change its gravitational pull on the Moon or the Sun's pull on the Earth?
Yes.
Yeah?
Next question. No, it's not as bad as you think, however, because if you take all of the asteroids in the asteroid belt and collected it together back into one solid mass, you can ask, how much is that?
Florida.
Okay, so it's about 5% of the mass of our moon. So 1/20th of the moon. And so we could accumulate all mass of all the asteroids and we would barely notice it in terms of our own weight. And the moon's orbit would adjust a little, but not much.
Right.
And so it's really not an issue.
Okay.
Yeah, nothing to lose sleep over.
Not scared of that.
And by the way, anything large enough that we did bring to Earth that would badly disrupt our orbit would be bad enough on Earth to render us extinct. So it would not be the kind of question you'd be asking.
Like Mars, if we brought Mars to Earth, that would be bad?
Very bad. Yes, that's the end of both Mars and Earth.
What's the most you could move Mars without it being a problem?
Well, you can put it wherever you want, and it'll affect our orbit around the sun, but not in any bad way. But if you want to combine them, that's bad for both.
Into a super planet.
Right, that's bad for both.
Okay.
Right.
Adrian asks, hello, Dr. Tyson. Would it be possible within our lifetime to extend people's natural life synthetically through either biocybernetics or bioengineering to such an extent that while they may not live forever, they might certainly be around for the next 100 to 200 years or more?
Yeah, so we got people working on this now. This is not science fiction. It's science fact. And people are thinking, the engineering of it, we hybridize biology with material science, perhaps. And maybe that's not even necessary. Maybe we just find the gene for aging and snip it, cut it, alter it.
What would happen? So how would aging work if theoretically you didn't age the way that things currently age? Because you'd still get older. Like you'd still have things.
You would be older.
Yeah.
To get older, we make synonymous with becoming more frail or weak.
Right.
You would be an older entity. Yes.
Right. So there would be a new type of frailty would develop, where just from simply being 200 years old, you might have a frailty that you didn't have. Is that what you're saying?
No, I'm saying if you live a long time beyond any current actuarial tables, it may be that the decline we see in our bodies from age like 50 to 80, maybe that would happen between age 100 and between 150 and 200, for example, right? But you have a bigger chunk of your time being alive you would be physically fit and healthy.
Right. You could play a lot more soccer.
It has huge consequences because that means the population of the Earth would go up, the human population, unless you made fewer babies, because the equilibrium of people and new jobs and all, it has built in the fact that people die.
Well, what if we just let only rich people live forever? Would that be something people would like?
Well, that's what happened in, what's the movie? Where time was a commodity. The time was a commodity.
Oh, yeah, and then there's
it wasn't money.
Where like they built the space station.
No, that's a
different movie. But there's a lot of movies where the rich people get to live for a long time. All right. Well, that's good to know that people are working on this terrible thing that will destroy mankind, but also be kind of fun.
No, I think to live forever, I've spoken on this before. I think that's misguided. Suppose you actually live forever.
Right.
Then what is the value of tomorrow to you?
Well, maybe if you just live for 200 years, then you still have like a little fear, but not as much as you have right now.
I just wonder, knowing that I'm going to die is a fundamental part of what creates meaning for any moment I'm alive.
Right.
And if a day goes by where I didn't like discover something or learn something or play with my kids or go on a play date with my wife or contribute to this world in some fundamental way, I wasted that day. And if I live forever, I would not have the state of mind that I could waste any time at all.
Right.
And I don't know what that would mean for people's creativity.
You could still be blown up in a war if that makes you feel any better. You mean not die naturally.
Right.
Yeah.
So I think living forever might be overrated.
Yeah, but living for 200 years, underrated.
Okay.
So it's a middle ground. All right. Erin asks, how are those fashionable, easily worn spacesuits coming along? Re the Mars episode of Nova Science Now.
Yeah, so I don't have the latest on that, but part of the challenge, of course, is the spacesuit needs to be pressurized because typically you're bounding around in some place that doesn't have normal atmospheric pressure, and it's got to keep your temperature regulated, warm when it's cold out and cool when it's warm out, and that can change on a dime, depending on what side of you is facing the sun, for example. And you want it to be flexible so you can still bound around a planetary surface and maybe do science experiments or just do sports, right?
Right, it's true. Maybe you want to play space tennis.
Right, or something. And when you do that, you want to have the mobility that a flexible spacesuit would give you. So I don't know the latest on that, and I should check up on that.
Okay.
By the way, if anyone is going to spend meaningful time on Mars, I'm thinking they're going to want one of these spacesuits.
For sure, because they're going to want to do Mars Tai Chi. They're going to do Mars cooking classes.
Yes, exactly.
Okay, Tyler wants to know, would a somewhat self-sustaining moon base drastically improve the likelihood of a manned Mars mission?
Yes. However, I think so. However, I don't know what it means to be a self-sustaining moon base, because where you're getting your food.
Well, I'm sure you'd bring a cow and you'd eat just a little bit of the cow. You'd keep it alive, like in that horrifying movie, The Road.
We would give us a lot of training just to moving stuff to another location, pitching tent.
Right.
But we shouldn't think of that as a stepping stone to Mars. It's way better just to go straight to Mars if you're going to explore space. But I happen to like the moon as a target for this because it's within a media cycle away. It's like 3 days away.
Right.
Right, when you launch from Earth. So you can check up on the astronauts, how you doing.
You could build like a sort of French Quarter like in New Orleans, but you could put it on the moon and you could have some jazz.
Yeah.
You could make it fun.
It'll be a place, an outpost.
Yeah.
A human outpost. So I think there'd be a lot of training for what it is to do that, what kind of supply chain of food you would need and other resources. And do you send up a doctor who can then, a surgeon? We get to think about how to make that happen.
If you had no training and you went into space, how sick, would you die or would you just be very upset?
Well, what would be weird is if you have a group of people that go to space and then a virus mutates, and then it affects just that group of people because you're all breathing the same air, eating the same food, and touching each other's bodies. And so then you have some weird virus that you didn't have vaccine against because it just arose in that moment. And so maybe this is the kind of thing you need confidence that you have way better control over the spread of viruses under those situations than what anybody's exhibiting today.
Okay.
Yeah.
Okay, so here's a question. Ramblin' Scott asks, oh, never mind. Yes, how much can you bench? But I'm going to...
Why don't you ask me? Why?
Sure. Okay, Ramblin' Scott wants to know, how much can you bench?
How much can I bench?
Sorry.
He didn't ask me on what planetary surface.
No, but I think it's implied that it's Venus.
Okay, so Venus has approximately the same gravity as does Earth, and so I'd be benching about the same. Mars, however, if you saw The Martian, there's the obligatory image of Matt Damon with his chest sticking out and his six-pack abs, because every movie, I think, has to have a guy with six-pack abs, so that we can completely delude the entire heterosexual female population into thinking that this is just a common thing on guys, right? This is just
people talk a lot about how men are subjected to these terrible standards, and it's so exhausting for us.
We can't live up to those standards.
Yeah.
And where have they heard that before, right?
Yeah.
So he's buff.
Yeah.
But there he is. You see him lifting these huge canisters up and down on the carry basin of the rover, and you say, well, he's buff, so that's why he's doing it. No, he was doing it because he's on Mars.
Right.
And if it weighs 300 pounds on Earth, it weighs 120 pounds on Mars, and so he can pick it up and put it where he wants. So they did this in the movie. They understood this.
Yeah.
And so, yes, it does help to be strong, but he doesn't have to be as strong as you thought he was.
Right. So then that would be a fun... So then boxing would be, or like ultimate fighting would be much more fun to watch on Mars because everybody would be so powerful. Or
no, you're not more powerful. Your punch doesn't have any more punch to it.
You could just lift a bigger thing. You could throw a bigger person.
Yes, you can throw people. Yes.
Okay, sorry. It would be fun to watch a throwing contest of people.
A judo match.
Exactly.
Oh, wait, yeah, you can flip people all over. So I would bench on Mars. So you take how much I bench on Earth, divide by 0.4, and then you get a bigger number when you're done, and that's how much more I can bench.
Okay.
A bench on Mars. But you notice I didn't say how much I can actually bench.
I'm sure on Mars it's between 300 and 700.
Yes, actually, that's a very, very good estimate.
Yeah.
Let's go to a lightning round.
Yeah.
Okay. The bell works.
Let's do it.
Okay, let's do it.
Okay. Higgs wants to know, how fast is the speed of dark? If dark matter emitted light, would it be the same speed?
Everything that is electromagnetic energy goes at exactly the same speed. So if your dark matter emitted any kind of light, which we know it doesn't, but if it did, and it had any kind of species association with light at all, even if it's a new band of light, because the light we know and love, microwaves, radio waves, gamma rays, these are all bands of light, all travels the speed of light. So do gravity waves, for example. So if it's going to send out energy through space, we're pretty sure it's going to be moving at the speed of light.
Right.
Okay.
Good.
Go.
What and why does it glow at the center of galaxies?
The center of galaxies, anytime we've had enough data to look in the center of a galaxy with precision, we find a supermassive black hole flaying and dining upon stars that come too close. And in the act of doing so, they become highly radiant just outside of their event horizon.
Okay.
And so, watch every center of every galaxy, including our own.
Okay, right. I'll watch it.
Good. Watch out for it.
Yeah. Do heavier elements get produced in black holes like a star with nuclear fusion?
If heavy elements get produced in the centers of black holes, I wouldn't know. Maybe, because matter is so dense, and we know what matter does under very dense situations.
And what is that, in your opinion?
You can merge nuclei and make heavier elements. Mm-hmm. This is what goes on in the centers of stars. So I do not know what the matter is doing at the center of the black hole after it has passed through.
Okay.
I do not know. Yeah.
Okay. When will New Horizons overtake the 2 Voyager spacecraft as the furthest man-made object from Earth?
So it turns out the Voyager, and I ran the numbers on this. Voyager 1, which is the farthest spacecraft from Earth, will actually never be overtaken by New Horizons, the New Horizons mission to Pluto, because the Voyager missions got gravity boosts upon going out and moving past Saturn, past Jupiter. Got a huge gravity boost, and at that point, it had more energy to leave the solar system than the New Horizons mission ever did. And so the New Horizons mission, we wanted there to get quickly, so we didn't have time to chase planets to borrow some of their orbital energy to speed us up. Not borrow, take some of their orbital energy to speed up. They went basically straight to Pluto. But if you're not going straight, you can meander, and as you meander, then you can steal orbital energy from planets and go out real fast. So it'll never overtake it. Voyager is the crown winner of that contest.
For now.
Right. Eugene, I think we got it. Wow, that was quick.
That was good.
Oh my gosh. We did the lightning round. You've been listening to Star Talk Radio, and I've been your host, Neil deGrasse Tyson, and that's been my co-host, Eugene Merman. Eugene, thanks as always for doing this.
Thank you very much for having me, Neil.
And as always, from this desk, I bid you to keep looking up. This is Star Talk.